Good morning, students. Today we will continue with our chapter number 10, Carbon and its Oxides. Today we will study about the uses of carbon dioxide. Carbon dioxide dissolved in water under pressure is used in making aerated drinks, such as soda. It is used to extinguish fire since it is neither combustible nor supports combustion. Solid carbon dioxide, that is dry ice, is a good refrigerant. It is used to keep the food items frozen. Carbon dioxide is used to make chemicals like washing soda and baking soda. It is used in the bakery industry. Baking powder containing baking soda, sodium bicarbonate, and potassium hydrogen tartrate is added to the dough of breads. On heating, it gives off carbon dioxide, which escapes, leaving behind the holes in the dough. This makes the cakes and breads soft and spongy. Carbon dioxide is used in making fertilizers such as urea. A mixture of 5% carbon dioxide and 95% oxygen, which is known as carbogen, is used for the artificial respiration in hospitals. Carbon dioxide is used by plants during photosynthesis. It helps to maintain the balance of carbon dioxide and oxygen in the atmosphere. It removes extra carbon dioxide from the atmosphere and restores oxygen. Carbon dioxide maintains the greenhouse effect of the earth, keeping the earth warm. An increase in the amount of carbon dioxide in the atmosphere leads to global warming. What we can do to reduce the emission of carbon dioxide? The methods which can be used are: we can reduce the number of kilometers of car driving by cycling, walking, carpooling, or taking mass transit wherever possible. We can support the local farmers' markets. They reduce the amount of energy required to grow and transport the food to us by 1/5, and we also get to save good money. So try and buy organic foods as much as possible. We should go for the CFL and tube lights. It saves 60% energy and our money also, while we save about 136.07 kg of carbon dioxide emission every year. We should clean or replace filters on our furnace and air conditioner. It saves 158.75 kg of carbon dioxide a year and also ensures faster cooling. We should choose energy efficient appliances when making new purchases. We should use less hot water. We should use a clothesline instead of a dryer whenever possible. Turn off electronic devices when we are not using it, and we should buy recycled paper products. It takes 70% to 90% less energy to make recycled paper, and it prevents the loss of forest worldwide. Carbon monoxide. It is an oxide of carbon which contains one atom of carbon and one atom of oxygen in its molecule. It is colorless, odorless, and highly poisonous gas. It was first prepared by Lesson in 1776 by heating zinc oxide with charcoal. It does not occur in the free state in nature. Coal gas, volcanic fumes, chimney gases in industries, automobile exhaust gases, and tobacco fumes liberate carbon monoxide gas in traces. Burning of charcoal with a blue flame is due to the burning of this gas. Fuel is a substance which on burning in air or oxygen produces heat or any other form of energy. When large amount of carbon or carbon compounds are burned in poor supply or insufficient supply of oxygen, it leads to the formation of carbon monoxide. Thus, carbon monoxide is a product of incomplete burning of carbon or fuel. When carbon dioxide is passed over red hot charcoal, carbon monoxide is produced. Physical properties of carbon monoxide. Carbon monoxide is a colorless and odorless gas. It is highly poisonous. If the percentage of carbon monoxide in the inhaled air increases to 1% or more, it can result in the death of a human being. It is lighter than air. It is sparingly soluble in water. Chemical properties of carbon monoxide. Carbon monoxide is neutral towards litmus paper, that is, it neither is acidic nor basic. It does not support combustion, although it is a combustible gas. For example, when a burning candle is introduced in a test tube containing carbon monoxide, it extinguishes. It burns with a blue flame to give carbon dioxide. Carbon monoxide reacts with oxygen, giving a blue flame and forming carbon dioxide. It is a good reducing agent. It reduces the metallic oxides to free metals. For example, ferric oxide reacts with carbon monoxide to form iron and carbon dioxide. Lead oxide reacts with carbon monoxide forming. Because of its reducing action, carbon monoxide is used in the extraction of pure metals from their ores. Reaction with the chlorine and sulfur. Carbon monoxide reacts with chlorine to form carbonyl chloride, and with sulfur it forms carbonyl sulfite. Uses of carbon monoxide. It is used as fuel and is present in the gaseous fuel mixtures such as producer gas, carbon monoxide and nitrogen, water gas, carbon monoxide and hydrogen, and coal gas, carbon monoxide, hydrogen and methane. It is used to purify nickel. It is used to prepare phosgene gas, that is COCl2, which is used in the dye industry and in wars. It acts as a reducing agent and is used in the extraction of metals from their respective oxides. It is also used to produce synthetic petrol and methyl alcohol. Harmful effects of carbon monoxide poisoning. Carbon present in its amorphous forms such as coal, charcoal and coke, which we have studied in the last chapter, is released in the form of carbon monoxide when they are burned in limited supply of oxygen. When carbon monoxide enters the atmosphere, it spreads undetected as it has no smell and is inhaled by the living beings. Since carbon monoxide has more affinity for hemoglobin than oxygen, it combines with hemoglobin, forming a stable compound called carboxyhemoglobin. This compound does not allow hemoglobin to absorb or carry oxygen and therefore reduces the level of oxygen in the blood. The symptoms that occur in the human body when carbon monoxide is present in the blood in small quantities are headache, nausea and fatigue. Excess of carbon monoxide in the blood may lead to suffocation, followed by the brain damage and eventually causes death. Thus, the poisonous nature of carbon monoxide is due to its reaction with hemoglobin in the blood. Now, the consequences is sleeping in a closed room where charcoal, coal or coke is burning. They burn in a limited supply of air as the room is closed. So they release carbon monoxide. As the gas accumulates in the room, the person feels suffocated, which eventually leads to the death of the person. Starting a car in a closed carriage. The exhaust gases from automobiles always contain a small amount of carbon monoxide due to incomplete combustion of the motor fuels. Therefore, a car engine should not be started inside a closed carriage. Standing behind a running engine of a vehicle. Automobile engines mostly contain petrol or diesel as a fuel, both of which contain carbon and hydrogen. When these fuels burn with the engine in a limited supply of air, carbon monoxide is formed and is emitted in the form of smoke. Thus, the person standing behind the running engine of a vehicle inhales carbon monoxide, leading to the carbon monoxide poisoning. Remedies for carbon monoxide poisoning. The person suffering from carbon monoxide poisoning should immediately be brought outdoors so that the person gets fresh air along with oxygen. The artificial respiration with carbogen should be given to the person feeling suffocated due to carbon monoxide poisoning to restore the normal breathing. A person going to place with high concentration of carbon monoxide should wear gas mask. Such masks absorb the carbon monoxide and oxidize it to carbon dioxide.